Oh, welcome back to our Chem 4 review. We are up to part 12, the concepts behind Raoult's law. Remember, there are two gas laws that pertain to gases and solutions. One was Henry's law that we just covered, and right now we're going to cover Raoult's law, the concepts. This is the concept. If you have a pure solvent like water, it's going to, inside a sealed container, it's going to evaporate. So then you're going to have gas above the water. That gas in turn is going to exert a pressure back down on the solvent. So this pressure is from the pure solvent, just water. Now, what happens if we add impurities? Doesn't common sense tell you that some of the molecules that want to evaporate can't because they're being blocked by the impurities? So when you add a solute to water or any solvent, less of the molecules can evaporate and become gas. Since there are less molecules that can evaporate, the pressure they can exert back down is also less. So if you add a solute to a pure solvent, the vapor pressure of the impure solution, the pressure from the molecules that can exert pressure, will be less in comparison to the vapor pressure of a pure solution. Because the impurity blocks evaporation. Less gas evaporates, so there's less vapor pressure from the evaporated gas back down on the liquid. So let's look at the formula for Raoult's law. The formula Raoult's law says the pressure of water plus a solute is going to be equal to the mole fraction, that's something new, of water, not of the solute. Be very careful, that's where students make their mistakes. The mole fraction of water, write the formula this way, times the vapor pressure it would be if it was completely pure. Mole fraction of water means you're going to take the moles of water, not the moles of solute, and put it over the total number of moles of solution, which means you're going to add the moles of water plus the moles of solute. You're normally going to be given the pressure for the pure solvent in a problem. So that's concepts of Raoult's law. We're going to cut here. We're going to come back in the next section and do a sample problem of Raoult's law.